Okay, good afternoon to everybody. On behalf of ETIP Hydropower, and because it's a special day today, on behalf of St. Nicholas, I would like to welcome you to that webinar, Boosting Hydropower, number 3, Best Practices for Research. So we will have a very tight program. We can go to the next slide. So you see here the agenda. So we will have, after a short introduction to ETIP Hydropower, we will have 4 presentations. You see them here. In order not to lose time, I do not read it down. I want, perhaps for all those who don't know what we are doing with ETIP Hydropower, I give just a very short introduction. Next slide, please. So ETIP Hydropower in principle is a European project with the purpose to create a sustainable organization which defends in future hydropower development in the framework of the energy transition in Europe. So with ETIP Hydropower, we enhance and disseminate 2 documents which we have prepared in the former Hydropower Europe, which is a research and innovation agenda, as well as a strategic industry roadmap. And we, with ETIP Hydropower, we will consolidate the strong network which we created in the former program into a sustainable organization, as I already said, which should help to unify the voices of hydropower in Europe. Next, please. So ETIP Hydropower will, in principle, help to unify the hydropower sector in Europe, as I've already said, presenting a kind of a single voice on key issues. But of course, we do not duplicate any other groups and associations which already exist. We like to enhance and to bring further up to policymaker all the messages, as you see in this anchor symbol. We are already working with the European Hydropower Alliance and with other organizations in very tight collaboration. Next, please. So hydropower under action. So we have an operational structure in place, which is a secretariat, and we have an industry-driven governance also in place with all stakeholders from all sectors, and we have a widely open scientific advisory board, 26 members, and you see here the persons which are involved. So myself, I'm the scientific coordinator of this ETIP Hydropower, and then we have the government board chair, Dennis Albrecht, government board co-chairs, Antonella Frigerio and Peter Stettner. Next, please. And what we have done, and that's all for all important who are working on research project, we have established a HERI platform which gathers all research projects which are ongoing in Europe, or we try to gather all of them in our platform, not only on the European Commission level, but also what is going on in the different European countries. Next, please. So we have also established 4 working groups, which are very active since early summer, this summer. So the first one is hydropower role for flexibility and storage, then hydropower and biodiversity, and the third one is hydropower and climate change, and then we have a cross-cutting working group, which is a promotion, dissemination and uptake of past and current European research and innovation project, which in principle organizes these webinars. So the working group will publish first results during our Hydropower Day, which is on 8th of April next year in Brussels. So the working group which is organizing this webinar, you see here we have about 20 members. So the chair is Emanuele Quaranta, who is the speaker today. And we have the general scope, as I've already mentioned, follow up the Horizon project related to hydropower. Also inform regularly with newsletter on the progress of these projects, and also to motivate and facilitate the organization of special sessions at conferences with hydropower as topic. So we intend to have a first session during 2025 in Thessaloniki in Greece. And what we are doing is organizing webinars. So we have today the third webinar in this series. Next slide, perhaps, please. So here, if you are interested to have more information, those who don't know it yet, so we have a website. We are also active on LinkedIn, and we have about almost now today about 1,000 stakeholders who have registered in our consultation platform, and which are contacted regularly on certain questions and get also information on any activities which we are doing with this ETIP hydropower. So the next slide, I think this is was a short presentation. I have now the pleasure to announce you Emanuele Quaranta. He is a scientific officer and hydraulic engineer at the European Commission Center Joint Research Center, and he will give us a first talk on a very interesting study which has been just finished recently. Please, Emanuele.
Thank you, Anton. I'll try to share my screen. Okay, can you see it? Because I cannot see you while sharing the screen. Okay, perfect. Thank you very much for organizing together with me this webinar. And I'm happy to be here. And today we'll present several activities we are conducting at the Research Center of the European Commission, in particular this recently published report that is an annual report. I work at the European Commission, in particular in the Ocean and Water Unit, where our aim is to support the policy-making process by providing scientific and practical evidence to the policymaker. And in particular, my Ocean and Water Unit is in the Joint Research Center of the European Commission, which is a directorate of the European Commission. Here you can find some of the water legislation that we have supported by our scientific research, and there are several of them very different, from water in agriculture to ocean, hydropower, rivers, and so on. So all the kinds of waters. Today I will talk about different activity. In particular, I will just provide a summary of the exploratory activity 𝗪𝗏, where we assess the European Union potential of new sustainable hydropower, in particular hidden hydropower. Then I will talk about water energy storage in pumped storage hydropower that is has been published a few days ago. And then the main topic is the Clean Energy Technology Observatory report. It is an annual report on hydropower and pumped storage hydropower. A slide to present the already finished exploratory research on sustainable hydropower. I already presented this result in the past webinars and at conferences, so I will just provide here a summary. We have discussed and published several results, for example, on the potential of refurbishment of the existing hydropower plants in the European Union. We have also provided an assessment on the use of hydropower in historical non-power barriers and non-power dams. We've also investigated the potential for hydrokinetic turbines and also the hidden hydropower in water distribution network and wastewater treatment plants. I could provide to you the references, but also in the report that I will discuss, there is a table with all these solutions with discussion and the data, like, for example, the additional energy generation that we can obtain by these strategies. Another important activity that we have finished is the quantification of energy storage in hydropower reservoirs and in pump storage hydropower. We found that in literature there are several sources of data, and often these sources provide different data. Sometimes this data on energy storage are not well defined. It's difficult to understand. For example, if they include the cascade effect or not, or if they are talking about a theoretical energy storage capacity or a technical economic one. So we try to do a bit of order in this and publish this a few days ago in this paper. Here a summary of our results. We provided data and calculation both for pump storage hydropower and also for traditional reservoir hydropower, calculating a sort of theoretical energy storage, which is practically the head multiplied by the volume of the reservoirs. Obviously, the smaller reservoir limits the potential. Then we have corrected this theoretical energy storage potential, calculating a technical energy storage potential, considering some reduction coefficient, for example, the efficiency, or the fact that not all the volume can be used for safety reasons. And we have compared this number with the reported energy storage capacity that we found in literature. We have found that there is an agreement, but there are also some differences, and these differences are well discussed in the paper. Now I will not go into the details, otherwise I will need hours, but you are encouraged to read the paper and also to provide your feedback and your constructive criticism. It is important also to show this data because by comparing this number with the numbers provided by other studies that show the future potential, it is possible to understand really how much is the future potential. And this is shown in these slides. Here is the energy storage capacity in the existing pump storage hydropower plant, the theoretical potential that I show you in the previous slide. So practically this number, 6.6, is this one. This is a logarithmic scale. And here you can find the results from other literature studies that have identified in the European Union the future, the possible potential of developing new pump storage in the European Union. And you can see that the opportunities are a lot. You can see that the available potential that can be exploited is the sum of all these strategies is much larger than what we have. So technically speaking, in the European Union, there is still potential of new pump storage hydropower. For example, from new closed loop pump storage or from new open loop, but also by interconnecting reservoirs or also by using abandoned mines. The problem is that most of this potential currently is not economic because of market limitations, but there is a potential. Here, the second part of this presentation is this CETO report. CETO is Clean Energy Technology Observatory. I am in charge of the hydropower section. Here you can see the list of all the topics that are discussed in this report. I will not discuss all of them today. I will just give emphasis to some topics, especially the ones that have a more industrial impact, since ETIP Hydropower also aim at unifying the voice of the hydropower industry. Some picture about innovation in the European Union. On the left, you can see the states, the countries that host the largest number of innovative companies based on investment. And you can see that in the list, there are several member states of the European Union. For example, France, Germany, Austria, Finland, Italy, Netherlands, Spain, Belgium. So European Union is quite innovative in the hydropower sector. Even if the growth of hydropower is not very high, the European Union companies are very innovative and export a lot of their innovation outside of Europe. On the right, you can see a focus not on the countries, but on specific companies. In particular, here is a list of the most innovative companies in the world based on patents, based on inventions. And here you can see there are 5 European Union companies in the top 10 companies in the world. If we have a look at the picture on the bottom, this is a look on the top 10 European Union innovative companies. So while the figure on the top is global, The one below is on the European Union, and you can see here the most innovative hydropower company based on their patenting activities. If we look at the scientific publication, in orange, we can see the scientific publication under the keyword of hydropower over the years. You can see that for the European Union, the main competitor is China, that also hosts 3 times more the population of the European Union. But after China, European Union is the highest. The blue one is the rest of the world, aggregating all the other countries. If we look at the export and import of European Union companies, here we really see the innovative characteristic of the European Union companies. If we look on the left, we can see that if we look at the global export of hydropower electromechanical equipment, so mainly the turbines and the related components, we can see that out of this global export, 45% of this global exports come from European Union companies. If we look instead at the picture on the right, these are the imports. We can see that the European Union also imports some equipment, but 74% of all the equipment that is imported from other European Union member states. So the intra-European Union trade is very relevant and important. Here you can see a picture about some environmental indicators of hydropower. I took this picture from the report of ETIP HYDROPOWER. So thank you, ETIP HYDROPOWER, Hydropower Europe, to share this report with these useful pictures. And you can see that hydropower has some environmental, the quality of some environmental indicator is better than the one of the other energy technology. If we look, for example, at the greenhouse gas emission for each kilowatt hour, or at the 𝗘𝗏𝗏𝗃𝗏 emission, or at the energy return of investment, and so on, we can see that hydropower has the best indicator. However, we have not to forget that there are some also impact associated to hydropower that are not captured by this picture, like, for example, fermentation, fish migration, and so on. So it is very important to implement mitigation measures. Here you can see a detail on the Horizon project funded by the European Union. In the blue bar are the number of projects financed per member state. The state that received the highest amount of number of projects financed under the Horizon program are Italy, Germany, Belgium, Spain, but there are also countries outside of the European Union, like, for example, the United Kingdom, Norway, Switzerland, and also African countries. If we look at the million euros that the European Commission is investing in the Horizon project, we can see that the average per year is more or less 10 million euros, with some peak every 4 years. Please note that these are only the Horizon project, but there are a lot of other projects on hydropower funded by the European Commission, for example, the Interreg projects or the LIFE projects that are not included in this picture. Here you can see the recent Horizon calls funded by the European Union. There are mainly 4 calls. The first is the development of hydropower equipment for improving techno-economic efficiency. Then there are other calls on innovative pump storage equipment or on novel long-term electricity storage technologies. And also another call on demonstration for sustainable hydropower refurbishment. So now I come to the core of this webinar, that is the presentation of these 3 new funded Horizon projects: RevHydro on the revolutionary refurbishment for an efficient and eco-friendly hydropower, SHERPA on a new solution for hydropower plants to enhance operational range performance and improve environmental impact, and STORY-HY, innovative storage technology and operation in hydropower. And as you can see, the topics of this project well aligned with all the discussion, all the data I show you about the European Union. So innovation, energy storage, and also reduction of environmental impact. Here are the references of the first is the annual report that was published a few days ago, and the second is the paper on energy storage. Maybe I can also write in the chat. So thank you very much. Now I give the floor to Anton that will present the next speaker. Thank you.
Thank you very much, Emanuele, for this very interesting presentation on the potential and strength of hydropower in Europe, which has been proven by the studies you have done. So we are pleased to come to the presentation of the first project, which will be done by 𝗤𝗏𝗻𝗄𝗏. 𝗤𝗏𝗻𝗄𝗏 is currently head of the electromechanical engineering team of hydropower generation division of Iberdrola in Spain. Please, 𝗤𝗏𝗻𝗄𝗏. We can see your screen. That's perfect. And
okay.
Yes, now we can hear you.
Can you see my screen?
Yes, everything perfect, yes.
Okay, thank you very much. Thank you for the introduction. Okay, thank you very much. Thank you for the introduction. I'm really happy to have the opportunity to be here and show a quick overview of this SHERPA project that is granted by the European Union. Thank you very much first of all, for the ETIP team, also for 𝗬𝗏𝗏 Innovation to allow us to come here and present this project that has just begun some weeks ago. So we are really happy with this opportunity, and we are 100% sure that it will be a really successful project. Let me move to the next. We are going through the main structure of this project. This is a project with a rough budget of almost 4 million. The project will span like 42 months. We have just started, as I say, last September. And one of the strengths of this project is that the consortium itself. This project involves a consortium of 7 partners, 7 entities from 4 countries. We have partners from Spain, Germany, Ireland, Belgium. So this is a really nice combination of entities. We have, I mean, myself, I represent Iberdrola Generación as a coordinator of the project. We are a utility with more than hundreds of years of operation and construction experience. We have a lot of knowledge for the stations through all of these years of operation. Also, we have the opportunity to collaborate with 𝗧𝗏𝗏𝗏, as the previous panelists show, is a reference in hydropower turbine manufacture, design, and develop. Also, we have IMEN, a Spanish research and develop expert. Also, EveryEurope, located in Ireland, as a specialist for methods, technologies, economical, and many in many fields of work in the energy sector. Also, in numerics, as an innovative software solution developer. ICOLD, really expert on water ecological issues, and 𝗬𝗏𝗏 Innovation that support us with dissemination, communication, and making possible making possible to expand all the knowledge that for sure we are going to develop here. And for sure we are in the way to collaborate with many stakeholders, and we are open to discuss and work together with as many people and engineers, science that could collaborate with us also. Okay. I have added this this slide, but maybe all of us are in the same point. We think that hydropower is the forgotten giant. I would say that we are here to develop all the possibilities to expand this resource that we think is the key for the development of other kinds of or source of energy, and to develop Europe. We think is the key for further advancement in many approaches. Okay. Getting into detail the SHERPA objectives. Currently, hydropower plants are facing several significant challenges. One of them are operating outside their design parameters. I mean, many stations have been commissioning in a different age with a different requirements. So nowadays the needs are fully different and out of the normal operating range. So we would like to go further and face that possibility and getting even more for them. Also, we would like to help and to support the new water quality and biodiversity. And here I take the opportunity to say that we would like to get energy for the composition flows, the ecological flows, and those ones are a dynamic value. So many times we have to lose production because those flows are in the really deep part load of the unit. So we would like to go there and trying to get back that energy and through the units. And also there are many maintenance costs that we are facing day to day, and within that applying cutting-edge technologies, we can save outage and cost from maintenance. Okay, so the SHERPA objectives are structured in these four main blocks. One of them are related with additive manufacturing, applying metallic patches and coatings to minimize cavitation. All of us know that cavitation is one of the main topics and difficulty to deal with. Also, we see that as nowadays the components from variable speed are day to day getting more in everywhere. Adapting the rotational speed could be an option from different places, and we would like to explore them. Also, we think that we can offer some improvements in water quality through air injection. Air injection is used widely in part load, but also in that places that we get loss or few amount of this oxygen on the water, and also go through those new designs for runners that give us, as everyone wants, units that we can run from 0 to 100%. So we would like to develop new hydraulics that allow us change just the runner, and we can use the same station, minimizing the investment and using the technology, using the new developments, trying to save money and make possible and economical feasible to use the data stations, minimizing the changes. The methodology that is structured in three comprehensive phases. Phase 1 is focused on definition of technical specifications and project requirements. So where we are, what we are looking for, looking into our needs. Phase 2, that is dedicated to the research and development solutions. It's structured in 3 different working packets that you can see there, that we are working in parallel, but into an iterative way, that if something is wrong, we can go back and move forward again and working all together. And phase 3 involves the practical demonstration of this solution in relevant environment. That means go to the stations and collecting data and putting those solutions into pilots and validate that the methodology and the solutions make sense. We have some cross activities that are working pack 7, and that is dissemination, communication, and exploitation. That that will be through all the projects as usual in these projects, and also we are going to apply everything with the indicators to understand the environmental, economic, and social impact of all the activities and all the outcomes. Now we are going through some of the pilot plans. Iberdrola Hydropower as operator of almost 12,000 megawatts in Spain, Portugal. We are going to use our own stations. So we have selected some stations with real needs from Mediterranean Basin and Seal Basin, and maybe another ones that now are under assessment. So I would like just to show some of them with some nice pictures of these stations and make you know that this station we are looking for the main objectives of this topic, operating the units with minimum changes in really deep parallels of them without any significant troubles. And some of them we are going to assess the changing of or using new hydraulics or applying those additive manufacturing. More places. I mean, we are not now in the first working package, so we are under the time of the definition of the requirements and discussing with all the partners of the consortium to know where it makes sense to apply each objective. So we are going to go through all of them, making a comprehensive and full assessment, and afterwards putting the efforts in all or at least in some of them. Okay. And just to move quick to the Seal Basin, here are some stations, and I would like to remark that some needs not always came from all the stations. Here we have these stations, for instance, that Alto Tàmega, this is one of the newest stations from Iberdrola that it was commissioning almost this or last year, and this station is used to launch reversible units from 𝗂𝗏𝗏𝗏𝗏. And for instance, here we would like to improve the water quality, as this reservoir is a new reservoir, and as you may understand, new reservoirs sometimes are in the way with many organic material, and during the first years we have to keep in mind and deal with the dynamic of the reservoir. And for instance, 𝗍𝗏𝗏𝗏 also is a new station, has 3 units. The 2 main units are big ones, and we have a third for the ecological flow, but here, for instance, it will be really interesting to deal with the deeper load of one of the main to cover the distance between the rated output of the small one for the ecological flow till the big units. And 𝗪𝗲𝗻𝗂 too, I would say also new station, but it came from maybe 10 years ago, and it's a big unit. It was made by one of our colleagues from 𝗏𝗏, and we have got many information for that, and as it's a huge unit, almost 200 megawatts, it will be really interesting if we can operate into a different manner, crossing the limits of the nowadays operation range. So just to conclude, here you can find the way to contact us. We are now working intensively with all our partners to start the project. We are as I say before, we are in the first phase with the specification definition and making that work to put all together to move forward with success. So I really thank your attention, and I'm really happy to be involved in this kind of project that is key to the future of the energy and the future of hydropower. So thank you very much.
Thank you very much, Vladimir, for this very interesting presentation. So I think it's a promising project, and we are looking forward to learn about the first results, perhaps in another webinar by the end of the next year, perhaps also at 𝗪𝗏𝗏𝗏𝗏, we see. So good luck for your promising project. I think you are a strong team. The results will be really promising. So we are coming now to the next presenter, or next presentation, which is given by Michel Cervantes. He has a PhD in fluid mechanics from Luleå University of Technology in Sweden, where he currently works as professor of fluid dynamics since already 2010. Please, Michel.
Thank you very much for your introduction, Anton. Do you see my screen?
Yes.
Okay, because I see you, but I don't see that. I don't know what I show you. So now you have you have the first slide, correct?
It's perfect. Yes, full screen.
Okay, thank you very much. So my name is Michel Cervantes, and I'm a professor in fluid mechanics, working at Luleå University of Technology in Sweden. And so I'm going to present you this Horizon Europe project, intitulated with the title Revolutionary Refurbishment for an Efficient and Eco-Friendly Hydropower. So a quick project overview. So the acronym of the project is RevHydro, and the duration of the project is 48 months, so 4 years. We in fact newly started the project the 1st of October, so a little more than 2 months ago, and we had our kickoff meeting the 15th of October. So the total budget of the project is 4 million euros, and the type of action, it's a research and innovation action. So the goal of the project is to enhance hydropower efficiency, flexibility, and sustainability while adhering to environmental and economic standards. So if we look at the consortium, we are 10 partners situated in 5 different countries. So we have Luleå University of Technology, which is the coordinator of the consortium. So Luleå is situated in the north of Sweden, near the Finnish borders. In France, we have 4 partners with General Electric, situated in Grenoble. So it's a turbine manufacturer where we will perform some model testing. We have RESCOL, which will help General Electric in the development of some flow control technology. And after, we have 2 utilities, Électricité de France, EDF, and Compagnie Nationale du Rhône, CNR. So in Germany, we have the University of Stuttgart, which will perform some comprehensive numerical simulation at the deep part load to quantify fatigues. The fourth country, it's Romania, with 2 institutes and 1 university. So we have 1 research institute, which is ICPE, which will work on the development of an intelligent fish barrier, together with the University of 𝗤𝗏𝗃𝗏, where a test rig will be built and the 𝗨𝗏𝗃𝗃 system will be tested. The second institute in Romania, it's RSEM, which is specialized in circular economy, and so they are going to work with this subject. And finally, but not the least, we have Switzerland with 𝗬𝗏𝗃𝗃𝗏 spécialisé de Suisse occidentale, which will work with LTU in the part load operation of Francis turbine in order to quantify fatigue. So if we look at the background of the project, you all know that hydropower is the largest renewable electricity source, standing for 59% of the renewables and 70% of the electricity production worldwide. So hydropower has some very good characteristics. It's highly flexible. In this case, I mean that we can start and stop hydraulic turbine very quickly, or we can change load very quickly. And for this quality, hydropower is widely used to support the introduction of intermittent renewable energy, such as wind and solar. This means that we need to operate, in fact, hydraulic turbines beyond design parameters. This increases wear and fatigue and decreases the life of the machine. So that is one of the challenges. A second challenge is like hydraulic turbine disturbs the fish migration. So we'd like in the project to try to develop some sort of universal solution, if possible. And thirdly, refurbishment are quite expensive. So we'd like to decrease such type of cost. So we can see on the right a figure where it's the operation of a Francis turbine, and we have some different pictures. So on the x-axis, you have the flow rate, and in the y-axis, you have a DH, which is the pressure pulsation, and H is the head of the machine. So Francis turbines are single regulated turbines designed to operate efficiently at an optimum flow and to run this optimum flow. But as soon as we start to close the guide vanes, we have an excessive swirl flow coming into the draft tube, which is going to lead to the formation of a rotating vortex rope. So such rotating vortex rope create axial and rotating pressure pulsation, which can excite the frequency of some component in the turbine and lead to resonance phenomena. So that is at part load operation. And as we further decrease the flow rate, we come in the deep part load of Francis turbine, and we have the RVR which disappear, but we have some channel vortex, so vortices between the runner blades which appear and substantially increase, in fact, the fatigue on the runner. We have also some fatigue appearing at part load operation to a lower level. So what we would like to do in this project is to substantially decrease, in fact, over a wide operating range, the pressure pulsation which are creating some fatigue on the turbine. So in order to achieve such type of goal, we have some specific objectives in the project, 3 of them. So we have the development of some flow control technology, some fish barrier technology, and we have some circular economy. So in terms of flow control technology, we have 2 technologies which will be developed. So the first one, it's in the draft tube, which consists in some guide vanes, which can be radially adjusted to mitigate the pressure pulsation at part load operation due to the rotating vortex rope, and which also have some variable porosity. The second flow control technology consists of a smart add-on, which will be installed on the runner in order to decrease the interblade vortices and the fatigue. So that it's there is already some work which has been done in this area, but it's quite new what's going to be presented. So in terms of fish barrier technology, so a fish barrier will be developed. It will not be this one. So the fish barrier technology which will be developed will consist of some bubble curtain, some acoustic source, and some strobe light source. So these three components will be adjusted depending on the fish species, the maturity of the fish, and the environmental conditions. So we will have some adaptive system. So the 𝗨𝗏𝗃 validation will be performed in Romania, where a test rig specific will be developed and enabling, in fact, the test of the 𝗨𝗏𝗃. So we will test 4 different classes of fishes, and the exact choice of the species depends on the reproduction process that will take place in Romania. So at the moment, we still don't know exactly which fish we will study. So in terms of circular economy, we aim to minimize the refurbishment impact and optimize the resources. So to this aim, we will develop some generic methodology to study and optimize refurbishment procedure. So we will have some life cycle analysis, life cycle inventory, life cycle costing studies performed. And a systematic approach for maintaining and extending the lifespan of critical hydropower equipment will also be developed. So if we look at the structure of the project, so we have 6 working packages. So we have the standard working package for the management, and 𝗵𝗶𝗵 for the communication, dissemination, and exploitation. So related to the specific objective, we have 1 working package dealing with the development of the runner flow control. So in this working package, we will have some experimental investigation and numerical simulation with the focus on the deep park load operation. While in VP2, it will be the development of the draft tube flow control. So here it will also be some experimental investigation on model scale and numerical simulation to develop the flow control device with focus on the park load operation. So in VP3, the intelligent fish barrier or 𝗨𝗏𝗃 will be developed. And here we will have some extensive experimental investigation with some living fish, in fact. So, and finally, we have working package 4, which is related to circular economy and will be led by RSIM. So VP1 will be led by General Electric, VP2 will be led by Luleå University of Technology, and VP3 will be led by ICPE. And VP5 will be also led by RSIM, and VP6 management, it's LTU, which is coordinating the project. So if we look in terms of workforce, we have a total of 430 person months. And the extension of the operating range of Francis turbine and efficiency, it's a quite important topic in the project because we have VP1 dealing with the runner flow control standing for 30%. And VP2 dealing with the draft tube flow control standing also for nearly 30%. So together, the extension of the operating range and efficiency stand for about 60% of the workforce. So the development of the 𝗨𝗏𝗃 will stand for about 15% of the workforce. Circular economy a little less than 10%. And after VP5 and VP6, the dealing with dissemination and management will stand for a little less than 20%. So in order to track the progress of the project and to align all the partners, some specific key performance indicators have been developed. So for VP1 and VP2, we expect to predict the pressure fluctuation and the strain from the numerical model within plus minus 20% of the experimental results. We expect also to predict the fatigue within plus minus 20% of the experimental measurement. So this modeling is quite important to develop the runner flow control device and the draft tube flow control device also for optimization purpose. In terms of efficiency and resilience, we aim to expand the operating range by 50% with the flow control device that will be developed. decrease the fatigue at by 80% at part load and deep part load operation. This will allow to extend the turbine life by 25%. Quite important also, it's to allow an increase by 1 order of magnitude of the start and stop without decreasing, without additional fatigue. So in terms of key performance indicators for the environmental impact, so we have some ambitious KPI. We expect to be able to redirect 95% of the fish from the turbine intake with the 𝗍𝗃𝗃 system. In terms of circular economy, so for the refurbishment, we aim to decrease carbon dioxide emission by 30%, reduce the resource consumption by 25%, reduce the operating expenses by 20%, and capex by 50%. So expected impact, we expect to increase the energy efficiency. So by reducing harmful off-design infrastructure, the refurbishment will improve energy production efficiency by up to 10% in certain operating conditions. In fact, I think that this number is quite conservative if the flow control device work as we're expecting to. So we will extend the operational range and the lifespan of the turbine, and so the refurbishment will expand the operational range of turbines by 50% and increase the lifespan by 25%, so reducing the frequency and cost of overhauls. So as mentioned, we will also enhance biodiversity prediction with the 𝗍𝗃𝗃, which aim to redirect up to 95% of the fish away from the turbine intake. So, and after, we will lower costs for refurbishment through to some circular economy methodology. So I'm finished with my presentation. Thank you very much for your attention. So the project is newly started, so all the social media are not really online at the moment. So within some time, everything will be in place. Thank you very much.
Thank you very much, Michel. So also this project is very promising. You started, so the purpose of this webinar is to increase awareness of really recently started project as you is, and also the one which we just have heard before. And we are also looking forward to get, let's say, information about the first results, for example, next year in one of our webinars. So thank you very much again, Michel. We come now to the third presentation, which will be given by 𝗥𝗲𝗿𝗵𝗵𝗏. He is associate professor at the Universitat Politècnica de Catalunya and the director of CETO UPC research group. Please, Michel. Please, 𝗥𝗲𝗿𝗵𝗵𝗏.
Yeah, I'm not sure if you can see my screen. No.
Not yet.
Ah, okay. Now I think.
Now we can see. Yes.
Yeah. Can you see it in presentation mode now?
Screen, yes.
Oh, yeah. Okay. So let me. Okay. So thank you for the introduction, and I'm going to start by presenting the project story. Okay. Well, I will speak first a little bit about the call, because we believe the call has some particularities. It's about the pumped storage, basically. I want to highlight, to explain to you somehow why, well, a little bit the reason of the proposal and the reason of some demonstrators that we took. We'll present the consortium of story, the outcomes, and then, well, the expected impacts and the strategy. So first of all, if we look at the goal we were targeting with this project, there were some keywords which I put here for summarize. One of them was increased availability of pumped storage, reduced OPEX and CAPEX in operations of pumped storage, improved efficiency. Also, Manuel has shown his report about how European industries are very competitive in hydropower. It's important to maintain the competitiveness and keep it in a good way. And finally, the sustainability of the innovative technologies, somehow to summarize some important aspects of the call. But here is when it comes some particularities. The call was mentioned that the development should be basically in these two directions. In one side, innovative PSP equipments and tools, and innovative storage management systems. So as you will see later in our proposed scheme, we have, let's say, we have clearly separated these two things. And also very particular of this call, it was that the technologies and the things that we are developing and testing, it should be addressed somehow unconventional schemes, okay, whatever it means, which could include low head locations, which is very typically in pumped storage, harsh operating fluids. The word saltwater was mentioned also, and it was also this idea of coal mines briefly mentioned in the call. So basically, when we were preparing our proposal, we were trying to address in a summarized way what you can see here. This is our consortium of Story. We are 21 organizations. The project, the budget is around 8 million euros for the let's say for the associated, for the European Union partners. We have also some partners from Switzerland and one from Norway. We have also partners from Spain, France, Portugal, Germany, Netherlands, and Belgium. We have many universities and RDI centers all around Europe. Two big utilities in hydropower, which have a long tradition in the participation of horizon projects in the hydropower context, such as EDF and EDP. And also we have UNOSA. I will explain a little bit later when I explain the demonstrators why UNOSA is here. Also, we have two important manufacturers, 𝗕Hydro and General Electric, industrial developers such as Sener, Kaizen, Sadim, and also we have 𝗂𝗏 and 𝗏𝗃𝗃 for the exploitation and the dissemination of the results of the project. So when understanding or when targeting the outcomes for our project Story, first thing is to understand from the techno-economically, regulatory, and environmental point of view, which would be the requirements for new pumped storage equipment and tools. This will be a dedicated part in our work. It will be the second work package. Later I will present the work package structures. And yes, based on this previous analysis, which has already started, some things that we will target, it's CAPEX and OPEX reduction of existing pumped storage plants, pumped storage hydro. Increasing operational capacity of pumped storage is also very important, because we believe that one of the directions that we should move is to be able to adapt, in some cases, pumped storage to harsh condition. For example, saltwater could be one direction. This will allow also to increase in the future geographical availability of pumped storage. Also to improve digital operational tools. We will have our package dedicated to digitalization of hydropower. And also, from the existing pumped storage plants that we already have, we will propose some idea to boost to improve the let's say the site, the utility, with low CAPEX cost. Okay. And finally, it's also to have in mind, it's important that the things that we are developing in Story, we want to be ambitious. We want to be that these technologies can be replicable and scalable to other demonstrators and to other sites, not only in the sites where they will be tested. So this is the look of the expected results. Is an overall scheme of the results. As I mentioned it before during the call, we can identify these two directions. One is pumped storage equipment and tool, and the other one is storage management system. That's why we we put our technical results in these two big pillars, what we call technological pillar. One technological pillar is more on the technologies, tools, which has to be adapted to unconventional storage schemes and harsh fluids. And the other big one is the operational and strategical management optimization. For every of these technological pillars, we have like some key technological areas. For example, here we have wear and tear monitoring and wear and tear evaluation, improved PSP equipment for saltwater. And in this side, in this technological pillar of operational and strategical management, we have the modernization and improvement of existing PSP. We will have also some demonstrators which are practically hybridized with battery and solar panels. So how to optimize this, or how to leverage hybridizations to improve the operation of these sites. And finally, to develop operational and decisions tools for control and maintenance. So basically, this is an overview of the 16 technical results. And as I said, they are all of them classified in one of these two technological pillars and in one of the key technological areas. Besides these technical results, we have some results or some ways to quantify let's say the engagement of the project and the exploitation of the project. These results are defined here. The structure of story, as my colleagues from the other projects, Michel Cervantes and Ademir, have shown in their respective projects, we have also kind of a similar approach, which is also typical in this similar structure, I would say, typical in this type of projects with a project management, also communication and engagement, which is kind of a transversal thing. But basically here I will comment the particularities in our project. We will start with techno-economical and environmental, social requirements. This will be somehow this work package will have a lot of activity at the beginning. This would be somehow the technical core of this project, which is one work package dedicated to digitalization, to develop digital tools that allow to make informed decisions and improve control. This is something that will be addressed here in this work package. Here on this side, we have improved technological equipment for harsh operating fluids and particularly saltwater, because we will have one demonstrator which uses saltwater, as I will show later. And then, of course, as this project is a TRL 8, technological level 8 project, we need to test and to validate the technologies that we are developing in a relevant environment, so in real demonstrators. So we have a lot of activities which will be tested and validated here in the demonstrators. We have also one work package dedicated to sustainability. For that project, we have, for example, University of Twente, experts on that type of evaluations. And we have also the exploitation of the project led by VGB. So a little bit more into detail into the core technical part. This is more or less how will be our approach. We will have the demonstrators. Our project is centered on the let's say on the data, on the operation, on the real operation of demonstrators. With the demonstrators, we can gain some data, but it's important to understand which data is relevant for our purposes, how to monitor this data, which signals are important to monitor, how to digitalize hydropower at the end. This is one key aspect. Then once we have, let's say, go to this monitoring phase, then the next part is what to do with this data. And this is, of course, something that needs to be addressed, and it's a big part of the work here. We will use classic approaches such as CFD and FEM tools, although they are classical. They are, as for example, Michel Cervantes has shown, it's very challenging to simulate some type of conditions. We want also to develop sediment transport models, the concept of virtual sensors, for example, for predicting stress and strain in the turbine, based, for example, on AI techniques. And based on this modeling, we want to develop meaningful condition indicators that at the end will support somehow the operation and to improve the operation of the pumped storage plants. Basically here, now I will speak about the demonstrators. We have 6 demonstrators in this project, 6 PSH sites, 3 in France, 2 in Portugal, 1 in Spain. I will go into detail in the next slide for these demonstrators, but what I wanted to show here is that before I have defined the results, and here we are explaining where these results will be addressed or where will be tested. So basically here we wanted also to have some repeatability of the results. So for example, if we develop one important result, we want to test it in more than one site with different characteristics, and this makes the things more valid. Looking at the demonstrators, as we have seen in the call, it was somehow required that we should address unconventional storage scheme or at the same time harsh operating fluids. And yeah, these are our demonstrators. 3 of them are in France, provided by EDF. The first one, this is 𝗤𝗔𝗔𝗺𝗃𝗀𝗄𝗨𝗃. This is a cascade of 3 reservoirs. And here, well, here maybe it's a little bit hard to see, but you can see somehow these 3 levels, these 3 reservoirs. Here, what it will be done is how to optimize the management of water and also in terms of energy of this system of 3 cascades, because well, EDF will install a new turbine here between the reservoir of 𝗤𝗏𝗏𝗏𝗏𝗏𝗏, which is the top one, and the south mortier. The other one is 𝗘𝗨𝗏𝗏. In 𝗘𝗨𝗏𝗏, it's a more classical scheme. It's very close to Grenoble, 250 meters, 250 megawatts. But here, what we are addressing is the harsh operating condition, and this is because well, we want to increase the number of start and stops to be more available to the market, to be more responsive to the market, and also here we will address the topic of the sediments, because in some situations these areas, they can have problems. The waters, they can have problems with the sediments. We will also address sediments, and particularly saltwater, maybe in one of the only big places which we have with saltwater in hydropower, which is La Vance in France, in the Brittany part of France. La Vance is a tidal power station, as you may know. They are bulk turbines, basically, but they have the ability of pump. So, well, in that power station, we will test new materials, coating. We will address the problem of biofouling. And, well, the main goal, and we believe this is an excellent test bench for testing, let's say, new technologies for possible future saltwater PSP places. In Portugal, we have also 2 very interesting demonstrators. One of them is 𝗥𝗏𝗏𝗏𝗏, which is maybe the only one with a triple hybrid pumped storage scheme. And when I mean triple hybrid, I mean it's a classical pumped storage, but together with a battery and together with floating panels, as you can see here in the picture. The main idea will be to optimize these 3 systems together in order to maximize the potential of 𝗥𝗏𝗏𝗏. And this one is 𝗵𝗏𝗏𝗏𝗏. 𝗵𝗏𝗏𝗏𝗏 is a multi-stage pump. As you may know, multi-stage pump, most of them were commissioned many years ago. And at that time, they were commissioned with, let's say, with a fixed operating point. It means they are not able to regulate. And in this case, what we want to show or what we want to test is by a low capex retrofitting in order to be able to regulate the power of the units working as turbine. In this case, this will be done or will be tested by the main inlet valve. Finally, this will be a small pilot, but also interesting, we believe. It's the pilot provided by UNOSA called Pozo Figueredo in the north of Spain, particularly in Asturias. Asturias used to be an area with high industry penetration of coal mines and so on, but as you know, well, the direction is to decommission coal mines. And yeah, well, the thing is that now we have kind of places and infrastructures which can be used or could be used theoretically to develop new pumped storage places. So here in this case, it will be a small pilot, 100 kilowatt, but it will be in a relevant environment, in an abandoned coal mine, and we want to test the pumping with dense fluid. So, and this is the last slide. So wrapping up, the story has already started as the rest of the projects we have seen today. It will last 4 years from 2024 to 2028. We are a consortium of 21 organizations. And basically, we target the reduction of CapEx and OpEx to boost durability and recyclability of the components, digitalization, improve digital tools for better operation and greater efficiency, and at the end, as ultimate goal, increasing operational capacities and geographical abilities of pumped storage. I think that was all. Thank you very much for your attention, and thank you, the organizers of ETIP Hydropower, to organize this type of initiative. Thank you very much.
Thank you very much, Alexander, for this very nice presentation. So I'm really impressed about the very large consortium you have. So almost everybody in Europe is involved in a way in that project. So I think that will be also very promising for the results. You have already certain results, but we are also looking forward perhaps in one of next year or the year after to get more information about what you have already achieved. So thank you very much for this presentation. So now we have in principle time about 15 minutes for questions to all of the presenters. So we invite everybody who is participating to this webinar to write, let's say, the question in the chat. For the time being, I do not see any question. Perhaps leave time to the people to put question there. I would perhaps start with one question to Emanuele. You presented, let's say, the potential of the reservoir storage. I'm a little bit astonished on the quite low value. So first, my question, did you include non-EU countries like Norway or Switzerland?
Thank you, Anton. The study was on European Union reservoir. So Switzerland, Norway, that host 1/2 of the European storage capacity, was not included in the assessment. It was just for European Union countries. But I know that Norway and Switzerland did host more or less the same storage capacity of the European Union.
Yeah. Okay. Then it's clear. Another question, in principle. Okay. You calculated the potential by just using the volume of the reservoir, but most of the reservoir, so that means that your number corresponds to the case that the reservoir is used once a year for the gigawatt hour. And
we calculated
a lot of reservoirs, they have inflow, so they are filled almost perhaps 1.5 times, 2 times, even 3 times per year. So of course, which increases then the potential generation of reservoir energy, which can be used at any time, of course.
Yeah.
You agree?
Thank you. In the assessment, we did not calculate the energy that could be generated in 1 year, but we define it as the energy that could be generated in 1 cycle.
Yeah.
So 1 cycle, for example, in a closed loop system, the energy that could be generated in 1 cycle is depends on the volume of the reservoir. Consider that it is completely empty in 1 cycle. We define it in this way to calculate it. So if in 1 cycle we discharge all the water in the upper reservoir, we obtain that energy. Obviously, in 1 year, that could be hundreds of cycles. Thousands of cycles.
Yeah, I'm not talking of pumped storage. I'm talking of the reservoir storage.
Yeah, indeed.
Of course, pumped storage closed cycle, it's clear. It's 1 cycle. But if a reservoir storage, then of course you have inflow to the upper reservoir, which allows to empty the reservoir several times compared to its volume. So that would increase. So that's important, let's say, for strategic decision, what you have really available for flexibility in case where the grid is in danger. And okay, I will read. I have just read a little bit. I think a future paper could be to focus on the winter, because the winter is the critical period in Europe still. And then there it would be interesting to see what is really available from flexibility and, of course, long time flexibility. But okay, the study is very interesting.
We consider this, so considering no inflow. So if we have to discharge all the volume in the reservoir, how much energy we could generate. But yes, if there is an inflow, we could always fill the reservoirs. But this is a number that practically say, in case of water scarcity, in case that we cannot fill the reservoir, how much energy we have there that we can supply in case of water scarcity, for example.
But anyway, in most of the reservoirs, for example, in Switzerland, there is inflow, and the inflow is sure. So there is not a huge difference in inflow, perhaps plus minus 20% per year. So there is for sure, and it's also in other countries, you have inflow in the reservoir. Okay, so but anyway, that's interesting. We have a question.
Yeah, there is a hand raised. We will give permission to this person to speak. Perhaps he can introduce himself. And apparently it's a question for Emanuele.
Yes, so I see the person who raised the hand. Can I see that? Who is it?
Yeah. They have permission. They need to.
Okay.
Unmute.
Yeah, basically. José Angulo.
So I see José Angulo. Is that right?
Yes.
Yes.
You need to unmute yourself.
He can unmute himself, and then he can ask the question. Is that correct?
Yep.
Okay. Please go ahead, Jose. Ah, yes, I see something.
Maybe it was by mistake, so in case he has the question afterwards.
Hello?
Yes.
Yes, no.
Yes, are you hearing me?
Yes.
Okay, thank you very much for the great presentation, and I appreciate your effort to give us more information, to share us all what you are doing so well. Please, my name is Jose Angulo. I am from Colombia. I am living in the large open pit mines, coal mines operation in Colombia. And I am in Canada doing my master in environmental studies. And my focus now is how to storage at large scale renewable electricity. And then I found in my hometown an open pit. It is a perfect synclinal to storage water, to put solar floating panels, and to pump water to the waste rock dams. But at the same time, it was one scenario, and the second scenario is a greenfield upper reservoir, just to gain more height. And then it's an amazing result in my thesis, but I have a problem finding good examples about the cost, because I am very sure if I have a perfect synclinal like I have, it is like a free dam reservoir. And then it is an open pit, a perfect open pit that you can gather water there. And then for me, in my concept, it is the cheapest way to store electricity in a synclinal. And then because you don't need to build a dam. How much costs a dam? And then, but I don't have in my research, I don't have good examples about the cost when you are using a synclinal, avoiding to do a dam to storage water in the lower level. And then I have a question for Emanuele, because Emanuele was telling that using, for example, abandoned mines is too expensive. In my concept, I agree with you in some cases, but in some cases it's very cheap. But I don't have papers or documents that I can use to put in my thesis about the cost. If you have experience, Emanuele, about the cost, or you know the other presenters, I appreciate your favor.
Yeah, thank you very much. Yeah, thank you very much. Indeed, there is a European project on this, which is called the Atlantis project. And indeed, the cost of pump storage in abandoned mines is not more expensive, it's cheaper. I did not see that is more expensive. I say that, for example, new closed loop and new open loop in the available site may be more expensive, not because the best site already been exploited. But for example, interconnecting reservoirs or using abandoned mines is a more sustainable and more economic potential. So I agree with this. And they cost less. And yes, I have some example of cost. So I don't remember now in my mind, but more or less I think is all the civil construction is avoided. So this is the cost reduction. But you can write me. I can put you in contact with the coordinator of the Atlantis project that is aiming at investigating this aspect.
I appreciate so much your help, Emanuele. You have my LinkedIn profile as well. I am following you, and then we can share that information. I will send you my email as well. Thank you so much.
Thank you.
Yeah, here, of course, the question is also, where is the mine? So in Europe, the mine is on the ground, and you have to have an upper basin somewhere. I guess in South America, you have the mines higher up, and you have the lower basin somewhere else, and you can gain probably even more head than so that's probably even more economical than the cases and we have in Europe, I guess. So, okay, I see also a raised hand by Youssef Azadi. Can you hear us? Seems not the case. Do we have another question on the list? I don't see.
There are several questions in the box.
Okay, I see now. Question, okay. We have a question from Bettina Geisseler. If she is on, perhaps she can directly raise the question. Or otherwise, okay.
Yes, good afternoon. Do you hear me?
Yeah, we can hear you.
For me, this, first of all, thank you very much. It was a very informative webinar. Thank you so much, Anton. With these coal mines, it was a new sort of operation for me. Before I had never dealt with this. So is it already somewhere in the world in operation, or is it an idea for the future? That's the first question. And the second question, is it in hard coal mines, which are, for example, in Germany, very deep in the ground, or is it in light coal mines like you have in the new Bundesländer, where they want to float these light coal mines, where they dig from above the coal and do not go underground? It's a question to Alexandre or someone else. Thank you very much.
Okay, thank you, Bettina, for the question. Maybe also Emanuele will know some information, well, because also, well, Emanuele knows a lot of information of the Atlantis project. It's a very interesting project. I meet the leaders of the project in the past EGU conference in Wien. As far as I know, and then maybe Emanuele can correct me if you know, they are not, let's say, in the megawatt scale. We don't have anything now working in Europe, although they are projects, or sometimes I have seen news, for example, in Germany, in Finland. Maybe it's foreseen that in Finland in a few years we will have something. I know from a case in Australia, as far as I know, is the most advanced one in the scale of the megawatts. But yeah, as far as I know, is what the information that I have about operating coal mines. In our case, in Story, it will be, because it's a small pilot and it's a kind of pilot at this stage, it will be in the open pit coal mine, so it will be not underground. So we will use the existing pit to make this scheme. I don't know, Emanuele, if you want to complement.
Yeah,
something.
I agree with you. Yeah. There are some projects ongoing at the research level, like yours or like the Atlantis, just to show how this option could be a possible future solution.
Okay, so the question will be regarding cost if you have to take the mine, yes or no. So that's a crucial question on the costs. So in some cases you cannot change completely, let's say, the underground water levels and conditions. So you cannot accept that water is seeping out. In some cases you can accept. So that will depend if you have to do some tightening of these mines before creating a basin. I see there is a question from 𝗵𝗔𝗿 𝗦𝗽𝗶𝗿 for Ademir. Please develop the goal of speed variation for flow variation. What type of units? As it seems to me, the speed variation is more related to the head variation. Very specialized question for you, Ademir. You are on mute, I think.
Ademir, you need to unmute yourself. We don't hear you.
Can't hear you. So you have there somewhere on this vertical list. You have
now.
What?
Now it's working. So thank you very much. I'm sorry for the delay, and thank you for the question. You are fully right, and this is one of the questions that we would like to develop here. We have got some information from different experience that that variable speed could help to reduce the flow rate, but mainly is focus on the variation of head. But here, the approach that we would like to look for is in the really deep part load. I mean, it's not a full converter. It's to have a different rotational speed for that reduced flow to fit with the ecological flow. And we would like to assess in each cases could be possible, or in each ones it makes no sense. And the approach is from hydraulics. I mean, we are not going to develop some power electronics or something like that. We would like to know through the different case studies if it makes sense or not, or even in case it makes no sense, it's nice to know why and where it could be possible. In the past, we have tried to study a Kaplan unit, a small one that is called 𝗿𝗠𝗲𝗍, but we cannot conclude if it's stable or not, reducing the speed for reduced flow rates. So we are going to work through that direction, and we know that the references is for a different approach. It's more for high head variations.
Okay, thank you, Ademir, for this answer. I see a question to Michel Cervantes from Elmar Kempten from Switzerland. You are presenting saving of 20% OPEX. How do you reach this amount of savings? Michel.
I think Michel had to leave. He wrote in a message.
Okay.
You can see.
Okay, yes, there is another question to Michel. Unfortunately, he had to leave. Let me see. Okay. Okay, I think that's, yeah. Anyway, if the question is on, let's say, registered here, he can directly answer them to that.
There is one person with a hand up, Lisa Benenson.
Okay, Lisa, please, the floor is yours.
Okay. Lisa,
yes,
you can
mute myself. Hello, everybody. This is Elizabeth Sasson, Vice President of ICOLD. And I thank you very much for this opportunity to watch all these advances in research and this in hydropower in Europe. It's not really questions I wanted to put forward, just to make some comments regarding Bettina's question for using mines. In Greece, there are a couple of projects going on right now. They're in the design phase, not yet under construction, using open pit during, this is part of the decarbonization project in two large areas in Greece that there were lignite mines. I wanted to comment on Emanuele Quaranta's presentation, that the key roles of hydropower generation is one of the issues we're trying to put forward in the World Declaration prepared by ICOLD, that Anton is very well aware of course, on the role of dams and reservoirs for climate change adaptation and energy transition, and these are very relevant. And we wish to have the support of all organizations to bring forward those roles and to support our World Declaration. And this Sherpa's, and about the Sherpa's objectives, probably Emanuele is aware of it, but sometimes it is not the case. I just wanted to bring out that these objectives are very relevant with the European Library of Mitigation Measures for Hydrological alterations in heavily modified water bodies under the Water Framework Directive. So just wanted to make this connection for if somebody is not aware of it, to pass this information. For example, to avoid the abrupt surge and to adapt to ecological flows. That's all from my side, and thanks again.
Thank you very much, Lisa, for this additional information and input. So I think that's important for these coordinators of this project. So we are close to the end. I have just a comment. So I'm happy to see that salt water is again on the table, even if it was a little bit abandoned during many years. So we had just a presentation in Hydro in Graz on the experience of, I think it's the only one which is in operation, really a large one, which is in Japan. So they gave quite a lot of experience on that. And I think in Europe it could be again kind of an opportunity. And very often I said, mainly in countries where they have to fight against forest fire, because these basins, they could be also serve as a water storage to fight against fire, for example, in Spain, in Portugal, but also in Greece. And I think that could be a kind of a multi-purpose pumped storage power plant for also fighting against these natural hazards.
Anton,
So, if you allow me, Anton, just one more addition that I forgot, but you reminded me, mentioning Graz, that next year Hydro 2025 will be in Greece, in Thessaloniki, and this gives an opportunity to also visit that area I was talking about, the ex-lignite mines that are going to become pump storage plants.
Thank you, Lisa. And we will try for Thessaloniki to organize a special session on the most innovative projects in Europe. So those we heard today, those we have heard in the other webinars, and those we will hear in other webinars. So we try to create a special session on that, on this project. That would be very nice.
And Anton, there is one last question. Yusuf, he has the hand raised. Maybe we can give him the voice for the last question.
Yes, Yusuf, can you just ask the question?
Can you hear me?
Yes, a little bit.
We don't hear you very well.
Okay, thank you very much. My name is Yusuf Ansari from a company from Baden from Ankara, Switzerland.
We don't hear you very well, Yusuf.
Do you hear me now?
Is it the question, is there an RLA methodology has been applied to your proposed monitoring to Alexandra? Is that the question?
Correct.
Because I read that online.
It's a Anton, can you please repeat the question, because I cannot. I don't know where to read.
Is there any RLA methodology has been applied in your proposed monitoring?
RLI. Sorry, I don't know what is RLI. Well, can you?
If you hear me, this is remaining life assessment methodology.
Yeah, remaining useful life. Yes, we will address this when analyzing fatigue. I mean, there will be fatigue analysis based on stress, and we want also to. As you may know, maybe Yusuf, the classical approach is based many times on SN curve, and then, for example, for fatigue in turbines. And we will apply this approach, and also we want to a little bit to understand how to, if it is possible, or which type of approaches could be used to be realistic in the fatigue assessment of hydropower. I think this is a very complex topic, particularly is one of my research fields. And it's something, one of the key points of the project when doing the assessment of wear and tear.
Which code you apply for fatigue assessment?
Which, sorry?
Which code?
Which code?
Yes.
There is now we are using some ASME code, but I don't know the exact number now, to be honest. And I think regarding that will come something new. I have written. It will come some standard regarding the fatigue evaluation. This should come this year or something like that, if I'm not mistaken. I have read that in one recent thesis I evaluate from the EPFL, and it was written that it was under, let's say, development a new code or a standard, let's say, for fatigue assessment in hydropower, which I think will be very interesting.
Okay, so I think
Anton, I see there is also another question from Andrea Battaglia. I can read the question, or if Andrea is online, can maybe not. Yes, maybe yes.
Okay, he asked, do you expect the growing occurrence of negative power prices?
Yeah, to be a driver for investment in pump hydro project. I don't know who should answer. Currently, I don't know. I don't have the answer now. But if the question was directed to me, I can forward this question to my colleague that work more from the energy grid system. Maybe they can answer, or if the other speaker have some comments on this, more market topic?
I think it's difficult to say today, so it will depend how wind and especially solar energy will evolve in Europe, about the installation and how the market conditions will be. But there are always already today negative prices in the market. And important for the pump storage is, of course, it's nice to have negative prices for pumping, but you need peak hours which have good prices when you are turbining. And the business case is very good. But it's a little bit difficult to predict what will happen in the market. But I guess negative prices will be always present. It depends only how long. So I think we should come to the conclusion. So I would
perhaps we can collect all the questions, and if there is something left, we can directly send them to the specific speaker.
Okay. So all questions which are written or can be still written in the next minutes will be answered by the speakers. So I would like to thank the speakers, Emanuele, Ademir, Michel, and also Alexandra. Alexandra, and I like very much your name as an engineer working in dam engineering. That's a perfect name. Yeah. So, okay, thanks a lot all who presented these three projects, and also Emanuele, who was motivating to organize also these webinars. I think that's a very good thing. And we will continue with other webinars in future, where we'll have also again new project, but also already results from the project which have been started this year. And we try to organize really in the next Hydro conference in Thessaloniki a special session on some of these European projects. I think that would be important also for this project to be present, because it's the largest conference on hydropower in Europe, normally 1,500 people coming there, huge exhibition. So I think that would be very good for visibility. And finally, we have prepared a special slide for you, because it's St. Nicholas today. So why does Santa love hydropower at Christmas? Because it's reindeer powered by hydro, of course. And it can go over lakes, because normally the lakes are frozen in winter. So thanks a lot to everybody. Have a nice final weeks for the year, and then all the best for the upcoming new year. Thanks a lot to everybody. Thanks a lot also to 𝗏𝗏𝗏 for the organizing, let's say, technically this webinar. Thanks a lot and have a nice evening. Bye bye to everybody.
Bye. Thank you.
Bye.
Thank you.